Have you ever wondered what would happen if you could travel at the speed of light for 100 years? Imagine the possibilities, the sights you'd see, the places you'd go. Now, according to our current understanding of physics, this scenario is, unfortunately, impossible. But it serves as a compelling thought experiment to delve into the intriguing concept of time dilation, a concept that bends and stretches our understanding of time itself. So, buckle up as we embark on this imaginary journey at light speed. To understand our journey's impact, we must grasp the fundamental concept of dilation. Picture a high-speed train with a passenger and an observer at the station. To the passenger, time seems regular, but to the station observer, the train passenger's time appears slow. This phenomenon is time dilation. Time appears to slow down for a high-speed object from the perspective of a stationary observer. It's a prediction of Einstein's theory of relativity. The faster you move through space, the slower you move through time. The speed of light being constant is key to this. In our analogy, if the train nears light speed, the time dilation effect is dramatic. The observer sees the passenger's clock ticking extremely slow, but to the passenger, it seems normal. Now that we understand time, how would this apply to our light speed journey? Imagine stepping into a spaceship and accelerating to the speed of light. What would happen to time? Allow me to introduce you to the concept of time dilation. According to Einstein's theory of relativity, moving through space at high speeds drastically affects time. The speed of light presents a peculiar scenario where time would appear to halt for the person moving at light speed. This is due to the fact that the faster you traverse through space, the slower your journey through time, a phenomenon dubbed as time dilation. This concept implies that while time would seemingly freeze for our traveler, life on Earth continues as normal. Time, in Einstein's perspective, is not absolute, but relative to the observer. Therefore, while our Voyager perceives time as motionless, those on Earth see it moving as usual. This introduces the paradox of light speed travel, where the traveler's journey seems instantaneous, but years could pass on Earth. So, after our 100-year journey at the speed of light, how much time would have passed on Earth? Well, that's a question for another scene. Returning from your 100-year journey at the speed of light, you'd expect a lot to have changed on Earth. And you wouldn't be wrong. But the real drama lies not in the Earth's transformation, but in the time that has passed. Time dilation, a mind-boggling outcome of Einstein's theory of relativity, would have been at play during your journey. For those on Earth, over a century would have ticked by. Cities would have risen and fallen, generations would have been born and passed away, all while you were zipping around the cosmos. Yet, for you, the traveler moving at the speed of light, time would have seemed to stand still. Your journey might have felt instantaneous, or maybe just a few fleeting moments. So, while you might have only aged a few seconds or minutes, your home planet would have aged a century. Time dilation, a fascinating concept that shows time is indeed relative. Let's delve deeper into this fascinating concept of time dilation by comparing the time elapsed on our hypothetical spaceship and on Earth at different intervals: 10 years, 50 years, and 100 years. First, let's look at 10 years. If you were traveling at the speed of light for 10 years, from your perspective, it might have felt like mere moments or even instantaneous due to time dilation. But for those on Earth, a full decade would have passed. Next, let's imagine you've been journeying at light speed for 50 years. While this might have felt like just a few minutes to you, on Earth, half a century would have passed. Your family and friends would be 50 years older, and the world would have seen significant changes. Finally, let's consider 100 years of light speed travel. As we've mentioned earlier, despite feeling like a brief moment to you, a whole century would have passed on Earth. Cities would have transformed, and entire generations would have come and gone. As we can see, time dilation results in drastic differences between the time experienced on the spaceship and on Earth, further showing how time is indeed relative and deeply influenced by the speed at which we move. Let's now take a moment to ponder on a 100-year journey at the speed of light. From the perspective of our hypothetical traveler, such a journey would feel like a blink of an eye due to the fascinating effect of time dilation. It's almost unimaginable, isn't it? While you, the traveler, would feel as if only a few moments had passed, an entire century would have unfolded on Earth. This drastic difference in time experience between the spaceship and Earth is truly mind-boggling. Imagine leaving Earth, traveling for what feels like only a few moments, and then returning to find that 100 years have passed. The cities you knew would have transformed, the faces you remembered would have aged or disappeared, and entirely new generations would have come and gone. This stark contrast underscores the relative nature of time and how it is deeply influenced by the speed at which we move. Time dilation is not just a theory, but a reality of our universe, a reality that becomes increasingly apparent as we approach the speed of light. As we venture further into the realms of space-time and relativity, we are reminded of the profound interconnectedness of time, space, and motion. This is the beauty and the mystery of our universe, constantly challenging our perceptions and understanding of reality.